Very good morning. Myself Dr. Shamal Sen. I am Associate Professor in IPS Academy, Institute of Engineering and Science, Department of Chemical Engineering. Today's lecture topic is treatment of industrial wastewater. Okay. Find the most important thing is why the treatment of industrial wastewater is a major issues in today's scenario. Actually, being the world's largest population and will be the second largest economy by 2050, we India have only the 4% of groundwater reservoirs in it. Means the largest population in the world and having only the 4% of water reservoir with us. At the same time, we have only 1/3 of area in India is lying under the severe water scarcity. Means more than 50% of Indian population don't have the pure water for their drinking purpose. At the same time, more than 80% of water which is directly gone through the sewage system without treatment. Means this 80% of water goes to the sewage system without treatment, and this 80% water, it is the household water. Means can you imagine how much percentage of water is gone to the sewage system? As I earlier said, 1/3 part of India lies under the scarcity of fresh water, and 50% of Indian population don't have the drinking water for them. But at the same time, we have enough rainfall in our country to fulfill the need of more than 1 billion people. But what is the issue? The issue of India is that we are able to capture only 8% of total rainfall, and which is lowest in the world. Means we have enough rainfall in our country, but we are unable to capture that rainfall, and we only able to capture the 8% of rainfall in our country. At the same time, the report which is published by Niti Aayog in year 2021, according to that report, more than 21 cities in India will face the severe water crisis या फिर 0 day. So this is a very crucial time. We have to think how the household water can be treated by any treatment and can be reused in the system. Okay. Now we are taking one example, that is actually I am talking about the industrial wastewater treatment, but out of that I am focusing on the textile industrial wastewater treatment. Being the world's largest population in the world, at the same time we are the second largest producer of textile in the world after China. So we are the second largest producer of this textile, and the textile industries are very famous for the utilization of huge amount of wastewater in it. Now we are the second largest producer of textile, and if we are talking about our country, we have more than 450 small units in India which are working as the textile units. Okay. Now the textile industry, if I am talking about the textile industry is again one of the largest sector and providing employment to more than 45 million people in India. Okay. And these textile industries are utilizing each and every step in their each and every step, like sizing, scoring, bleaching, dyeing, finishing, and this is the final product. Okay, so this is the very basic steps which are normally used in the textile industries. Okay, but this each and every step uses water as a raw material for their processing. Sir, slides. हाँ हुआ अभी, ठीक है। अब ये फिर से यहाँ से कट करोगे क्या? ओके ठीक है, ओके फिर ठीक है, ओके फाइन, ओके हाँ। दिस slide now presents which is showing that India is the second largest producer of textile. Okay, and this slides presents the n number of unit operations which is carried out in the textile industries, which ultimately each and every step utilizes the water as a raw material in it, like sizing, desizing, scoring, bleaching, finishing, and ultimately the final product. From this each and every step there will be a huge generation of water. Okay, and ultimately if we are talking about the textile industries utilizing n number of chemicals. This slide presents the how much of chemicals our textile industries unit operations are using, and at the same time generating a very high concentrated wastewater. This wastewater having a very high concentration of COD, that is nothing but the chemical oxygen demand. BOD, that is biological oxygen demands. It having high concentration of color at will, having high pH, normally alkaline. The wastewater having itself total dissolved solids, total suspended solids, total solids. It's have phosphates, nitrates. Okay, so the wastewater which is generated from textile dyeing industries it's characterized by this COD, BOD, high pH, high color, presence of phosphates, nitrates, sulfates. Okay, so if this wastewater, I'm talking about the small scale industries. Actually in India there are n number, actually we are the second largest producer of textile in the world. So we have large scale of industries as well as small scale of industries. But large scale industries having their own wastewater treatment technology, and they are able to use that treated water in the system. I'm talking about the small scale industries which are not utilizing the proper wastewater treatment technology, and they are unable to reuse the wastewater in their system. Okay, now what they are doing, they are just neutralizing the wastewater and they throw that wastewater into any nearby water body resources. Okay, if such type of highly concentrated wastewater will disposed any nearby water receiving body, it will definitely damage the aquatic system, because there will be no penetration of sunlight through the up to the bottom of that particular water body, and if there is no penetration of sunlight, no photosynthesis will carried out, and ultimately it deteriorates the whole aquatic system. So this is the reason there is necessary to focus on this particular small scale industries and make a some what can I say, make a some cost intensive treatment technology to be easily available to this particular industries. Okay, now this is the general characteristics of the textile wastewater. Fine, there are scoring, bleaching, mercerizing, dyeing. These all units are utilizing huge amount of chemicals for the processing of textile. Actually, one there will be the 200 liter of water is required for the manufacturing of the 1 kg of textile fabrics. So can you imagine the huge utilization of water in particular textile industries? So the COD from this particular each and every unit is very high as compared to the BIS discharge standards given by BIS or CPCB India. Okay, we can follow any one of them. So the maximum COD limit of this particular textile industry wastewater should be less than 250 mg per liter. Color, it should be colorless. pH, it ranges from 5.6 to 9. BOD should be less than 30 mg per liter. Okay, total dissolved solids, total solids, chlorides, sulfates. Okay, these all are given in this particular table. Can we imagine the COD of particular textile industry wastewater is range up to the 40,000 milligram per liter. So we have to imagine the degree of treatment is required to treat the textile industry wastewater. Okay. There are n number of treatment technologies are available to treat the textile industry wastewater. N number of treatment technologies are available. N number of. But particularly that treatment technologies are called as the physiochemical treatment technology or conventional treatment technology. Now, if I will not go in the detail this particular, actually the conventional treatment technologies are available for the treatment of textile dyeing effluent are the very common. N number of industries which are working in India, they are utilizing the biological treatment. Biological treatment is normally used for the treatment of textile industry wastewater. This biological treatment definitely is divided into the two parts. First will be aerobic and second will be anaerobic. Fine. If I am talking about the aerobic treatment technology, ultimately everyone knows it and it uses the oxygen. Anaerobic, it is not uses the oxygen. Normally the famous treatment technology is the aerobic treatment technology. In aerobic treatment technology, the number of industries are still utilizing the traditional treatment technologies, and these are these aerobic treatment technology. First is the trickling filter and second is the activated sludge process. Now what is this particular process? The basic of this particular process is they having the big pond. Okay, and from the bottom of that pond, there are the trickling filters are available, which are continuously rotating the wastewater on the particular filter media. Okay, and from the ground, there will be the rotary filters are at the some height from the ground. So ultimately, the oxygen which is present in the air get mixed with the water, and ultimately the treatment of that particular wastewater is carried out. Actually, this wastewater contains bacteria in it. The wastewater contains microorganism in it. So ultimately, on that filter media, that microorganism degrade the organic matter which is present in the wastewater, and ultimately from the under drains, that wastewater goes to the settling chamber. They settle there, and after that, that treated water can be used in their particular unit. Either that treated water may be utilized for the power generation, or that can be recirculated into the system. Okay, this is the basic working of the particular trickling filter. Okay, fine. The next aerobic treatment technology is the activated sludge process. Now how it works? This activated sludge process are nothing but the big settling tanks in which actually the aerators are already fixed. The aeration time is from 4 to 6 hours. The wastewater, actually the wastewater contains microorganism in it. It contains organic matter in it, and that bacteria will degrade that organic matter with the help of oxygen and ultimately degrade that organic matter from the wastewater. Okay, so this is the famous aerobic treatment which is normally utilized in the textile industries. Okay, now nowadays but actually the major drawback of this particular system is the uh, large retention time. Means it is not like that if the wastewater will treat within a day. It will take near about to treat that particular wastewater a weeks. So it is a critical process. It's required lot of area is required for this particular aerobic treatment. It at the same time it requires a skilled supervision. It requires lot of time. It requires lot of energy. So this is very clumsy process right now. So instead of utilizing this traditional biological treatment to treat the textile industry wastewater, nowadays there are n number of again treatment technologies are available, like as membrane techniques, like physiochemical treatment technologies, electrochemical treatment technologies. Okay, electrochemical treatment technologies is nowadays going to very popular to treat the textile industry wastewater. In electrochemical technology, there is a use of electricity is used to treat the wastewater. Physiochemical treatment technology use the chemicals to treat that particular textile industry wastewater. In membrane technology, there will be the use of the either reverse osmosis, ultrafiltration or nanofiltration techniques. Okay. Now, the current slides now presents the there are n number of advantages and disadvantages of this particular treatment technologies which I just discussed with you all. If I am talking about the physiochemical treatment, that is coagulation and flocculation. Now what is the disadvantage of this particular process? Coagulation and flocculation means we are adding some chemicals to that particular wastewater and treatment is carried out. Means if we are adding something in a wastewater, what will happen? There will be the huge generation of sludge, and this sludge is the treatment of this sludge is again a very difficult process because it contains a huge amount of water in it. So dewatering of this coagulated sludge is again a major issue. Okay, so this is the major disadvantage of this particular coagulation process. Now ozonation is again one of the good treatment technology and can be applied on particular textile industrial wastewater. But this ozonation is useful for the only some class of dyes because the textile industries are utilizing huge amount of chemicals. They are normally use dyes and dye stuff for the as a coloring agent, and these dyes are very difficult to reduce by any physiochemical treatment. So ozonation is a good option, but it can be used for a particular group of dyes. Okay, so this is the major disadvantage of this ozonation treatment technology because it cannot be applied to all types of dyes which are used in the textile industries. Now the again popular treatment technologies that can be applied for the treatment of textile industrial wastewater, that is the Fenton process. This Fenton process is the again one of the good option which comes into the category of the advanced oxidation process. But this advanced oxidation process is used only when we required a very high degree of purity, because the cost of this treatment is very high. Means the Fenton process can be applied for the pharmaceutical wastewater because I am concentrating on a efficient treatment technology for a low cost low budget textile industries, because there are n number of small scale units which are currently running in India and they are not utilizing any type of treatment technology because all this wastewater treatment plant is a cost intensive. Maintenance is required, land is required, energy is required, cost is high. So Because of all these reasons, they are not using any treatment technology. They are just neutralizing their wastewater and throw that wastewater into any nearby water receiving body. As I earlier said, more than 80% of household water goes to the sewer line. So there must be some cost intensive treatment technology to treat this household wastewater, and that household treated wastewater can be used in the toilets. It is a very big amount that we are throwing more than 80% of our water into the sewage lines. Okay. Now adsorption is again one of the very good treatment technology and can be applied to treat the textile industrial wastewater. But the issue with the adsorption is that the regeneration of catalyst is again a very cost intensive technique. Ion exchange, electrochemical oxidation, aerobic treatment I have already discussed. Anaerobic treatment. This anaerobic treatment can be applied, but actually it is the major is the longer retention time. So this is the major drawback of this particular treatment technology. Okay. Advanced oxidation process actually can be applied. It is again a very good, very effective treatment technology, but again the problem is that there is a requirement of the chemical is very high, and if we are adding some chemicals into the wastewater, so there will be again the issues related to the high sludge generation, and if we are collect that sludge, so the sludge treatment is also again a major issue. We have to treat the sludge, we have to dewater the sludge, we have to dispose that sludge, we have to transport that particular dried sludge from your plant site to some other site, you have to reuse that sludge. So these are the issues related to the advanced oxidation process. Same issues with the membrane separation. We can use the ultrafiltration, nanofiltration, reverse osmosis, and membrane separation can be applied to the all types of dyes, but again it is a cost intensive process. So besides having all these treatment technologies like photophantom, coagulation, aerobic, anaerobic, which came under the category of biological treatment, means I am talking about the physiochemical treatment technologies, biological treatment technologies, membrane separation technologies, having the n number of treatment technologies, but all these treatment technologies have their some limitations. So nowadays researchers are focusing to a cost intensive treatment technology which can be easily applied on the textile industry wastewater to particularly the small scale units which are running in our country. Fine. So I am focusing on the electrochemical technology. Okay. Now this electrochemical technology is nowadays popularly known as electrocoagulation. Okay, fine. Now this electrocoagulation, you can particularly see in this process in the PPT. Electrocoagulation is nothing but the electrolysis of the wastewater. Okay, you already studied this electrolysis. There are electrodes placed in a reactor with a specific distance in between them, with a specific distance with the bottom, and these are connected to the DC supply. So this is the very basic diagram I am drawing. One is called cathode. These are the electrodes. Okay. One is cathode and one is anodes. Okay. Why this treatment technology is nowadays popular? Because it is very simple to use. This treatment technology is on-site treatment technology. It is environmental free. It is open to the atmosphere. Okay. So due to all these reasons, the electrocoagulation process nowadays is being popular and is easily applied to all types of wastewater to treat the particular their wastewater. Again, it can be applied to a small unit or a larger unit. Okay. Now first just understand how these electrolysis of wastewater or electrocoagulation system works. In diagram, I am just showing the two electrodes, but basically in electrocoagulation process, which is showing in their PPT, there are 4 parallel electrodes are connected with the DC supply. The DC supply can be replaced by the solar power also. So if we connect this electrocoagulation system with the solar power, we can strongly say this is the renewable energy system. We are utilizing the energy by the solar and we are treating the wastewater. Okay. How the wastewater is then treated in this particular electrolysis unit? Why am I calling electrolysis? Because actually when we pass the current through the water, there will be the dissociation of H2O. It can be converted into hydrogen and oxygen. How? Let's see. This treatment technology is known as the electrocoagulation. Means coagulation is done electrically. Actually, when we supplied current into the wastewater, what will happen? I am just for an example, consider these electrodes are made up of aluminium. It will release ions into the wastewater. As soon as the current pass through that particular wastewater, what will happen? That metal ions will release into the wastewater, and actually that wastewater contains organic matter in it. Then what will happen? They will form metal hydroxides. Okay. They will form the metal hydroxides, and ultimately what will happen? After some time, the impurities which are present in that particular wastewater will get absorbed on that metal hydroxides. And ultimately these metal hydroxides will get heavier, and after some time ultimately they will settle at the bottom of this reactor. Then we switched off this system, and ultimately this sludge can be recovered from this particular reactor or unit, and our desired degree of treatment is received. So this is the very simple, very basic functioning of the electrocoagulation system. Okay. So, but as efficiency of each and every treatment technology, it depends on its operational parameter. So, the efficiency of this electrocoagulation is also depends on its operational parameters, because each and every system required some operational parameters. Operational parameters means, if I am talking about this reactor, it must have some volume, it must have some this electrodes size, electrodes shape, electrode material. These electrodes will not touch to the bottom. There will be a continuous steering. So we required magnetic stirrer in it. Then the speed of this stirrer is also an issue. The supply of current is again also issue. Okay, so all these are known as the operational parameter. Fine. So for the particular electrocoagulation process, there are some operational parameters are required to reach the highest degree of treatment, because until and unless we are not able to get the highest degree of treatment, we cannot say strongly this treatment technology can be applied to this particular wastewater. Okay, so there are some operational parameters on which this electrocoagulation system is based. The very first operational parameter, as I earlier said, the pH of textile industry wastewater is very high. It is in the range of alkaline range. So pH is the very first operational parameter during the treatment of any type of wastewater. Okay. Now for particular this electrochemical technology, the second operational parameter is the current density. Now what is current density? As I said, electrodes will put into the wastewater. Okay, fine. When electrodes were put into the wastewater, that electrodes must have some specific area, because until and unless that electrodes have specific area, they are not able to release metal ions into the wastewater. Okay. Now what is current density? That specific area by the current. So this is nothing but the current density. The next operational parameter is the electrode gap, because I just said before, in electrocoagulation system we can use basic minimum 4 electrodes. It can be used on 2 electrodes also, but the efficiency or the desired degree of treatment will not achieved. So if I am putting the 4 electrodes into the reactor, there will be some minimum distance between that electrodes. So this is known as the one of the operational parameter. I am giving the example of aluminium. Any system can use iron, copper, TiO2 coated particles, or the combination of aluminium, iron, copper. So there are n number of electrode material available nowadays. So electrode material is again one of the important operational parameter. Now if I am saying that the DC supply into the wastewater with the help of electrodes, to carry the electricity into that wastewater, so it must having some conductivity in it. If there is no conductivity in that wastewater, there will be no electric flow into that wastewater. So conductivity is again one of the most important operational parameter when we are considering the electrocoagulation system. The next important parameter, that is known as the passivation. If we are using this particular electrocoagulation unit for a prolonged time, what will happen? That metal surface is coated with again impurity on it. This is known as the electrode passivation, and ultimately there, if continuously coating of this metal hydroxide on the surface of electrode, the generation of metal ions is again reduced and ultimately reduces the efficiency of that particular treatment technology. Hence, this is also a very important parameter when we are talking about this particular electrocoagulation system. Electrolysis time is again very important parameter. Okay, the minimum time of this electrocoagulation unit is 100 to 120 minutes. It is sufficient to treat that particular wastewater. If the electrolysis time is lower or higher, ultimately if we can increase the electrolysis time, ultimately the efficiency, we cannot alter the efficiency. Ultimately, we increases the cost of that particular electrocoagulation system. So, electrolysis time is again taken into consideration while designing the electrocoagulation unit for that particular wastewater system. Okay. So, there are again some parameters which are taken into consideration while discussing about the electrocoagulation unit, but I am point out this major operational parameter which must be taken care during while designing of the electrocoagulation unit. This slides presents some of the reactions which are carried out at the electrodes, because I already said it is nothing but the electrolysis of water. So, if there will be electrolysis of water, oxygen and hydrogen will definitely generate at respective electrodes. Okay. So, anodic reactions are generation of the metal hydroxide, and ultimately that impurity will adsorb on metal hydroxides, and there will be the ultimate degree of purity, or you can say degree of treatment, is achieved in case of the electrolysis. Okay. But from these reactions you can observe again one thing: there is a generation of hydrogen gas and oxygen gas respective on cathode and anode. Means there is a generation of hydrogen gas at cathode and there is a generation of oxygen gas at anode, because it is a electrolysis of water. If there will be the electrolysis of water, there will be generation of oxygen and hydrogen. So again, one of the beauty of this electrocoagulation system is that if I said there will be the generation of H2 gas and O2 gas, can we able to store this as a fuel and used into the system? So nowadays there is a more focus is done on the how hydrogen is generated by a renewable sources. So again, this is the good example. You can done the electrochemical treatment on the particular textile industry wastewater, small scale textile units. They can use this particular electrocoagulation technique, and ultimately the treated water, they can reuse that treated water into the system or for the power generation. And during this electrocoagulation system, if there is a generation of hydrogen gas, you can measure the volume of that particular hydrogen gas generated during that particular process, and can be stored that particular generated hydrogen and can be used in the system, or it can be used as the fuel, because storage and transportation with the hydrogen gas is very difficult. Okay. So this is all about the treatment technology, that is efficient treatment technologies can be applied to the small scale textile industries. So I can strongly say this electrocoagulation treatment technology can be easily applied to the small scale industries, because it does not require on-site treatment. It does not generate a huge amount of sludge. The sludge generated by this electrocoagulation treatment technologies is easily dewatered. Means there is a no bound water in it. It can be easily dewatered. Okay. It is environment freely treatment technology. If we can replace that DC supply with the solar power, so it is renewable treatment technology in nature. So it is environmental friendly. It does not generate carbon dioxide into the nature. It is open to the atmosphere. It can be applied on site. So all these are the advantages of this particular electrocoagulation treatment technology, and it is a very good option to any small scale industry. Either it may be restaurant wastewater, or it may be the pharmaceutical, or it may be the distillery, or it may be the textile industry, or it may be the slaughterhouse wastewater. So it can be applied on variety of wastewater. Okay. So this is all about the industrial wastewater treatment technology. Thank you.